So, in the one of the previous videos, we have in fact derived the expression for partition function. So, what was the expression? Q and Vt is equal to sum over r exponential minus beta er. So, this was the expression which we derived, right? So, basically ER is the energy levels in which the different microstates of this canonical ensemble are distributed. So that is how we define the partition function, right? Basically partition function describes how an ensemble is partitioned among various microstates, and the criterion for this partition is the energy level ER. Now in this video we will try to make this this expression for the partition function to accommodate more real situations. In statistical mechanics, this is one of the challenge always we have to explore, because statistical mechanics, since it forms a bridge between the classical and the real, and also the quantum and the real. So therefore we have to always explore how can our expressions be closer to the real situation. So in this video we will try to do calculate some of the alternate expressions for partition function. So that is our aim. So the objective of the class is to find out some of the alternate expressions for the partition function. Now the basis for this alternate expression is one of the major thing which we know. It is that most of the energy levels which we are talking about as ER are actually degenerate levels. What is meant by degenerate levels? These are infinitesimally close levels into which one of the energy level is being divided. This degeneracy must have been introduced to you earlier in your quantum mechanics courses or whatever. I'm not delving into that. Of course, you can ask me ask me to get clarified during our interaction session, but I'm not delving into those things in this video. So in any case, this a particular energy level is divided into different closely spaced degenerate energy levels. So and also we know that it is told that this kind of the number of degenerate levels or the degeneracy is one of the indicators of the weight factor for a particular energy level. How many closely spaced levels are there? That is one of the indicators of having that energy level more probable, right? So therefore, so we will try to accommodate degenerate levels into the expression for partition function. Now let's imagine that I have GI number of degenerate levels. So then in that case, I can rewrite the expression for partition function as meaning this is what as Q1 Vt is equal to sum over I or you can write GR, there's no problem. I really don't know. And so the QNBT is equal to sum over GI exponential minus beta EI. So this represents the what? This represents the my degeneracy. Now, of course, I can always represent the probability expression get modified accordingly. Pi is equal to GI into exponential minus beta EI divided by sum over I GI exponential minus beta EI. So, and if you go back to your derivation in which we derive this expression, we can always accommodate this GI into our derivation from the very beginning. There is no harm in doing that. But only thing is that it will be a bit more complicated to do the steps. And always I can now see one of the explanations or one of the points about the partition function, which I told you in one of the previous videos, was that partition function really represents the weight and what was the exact word I used? I forgot. I was telling you about the connection of the partition function with the sum of states, right? There I must have told you that this partition function always represent a weighted number of states. A weighted number of states a system can occupy. So there, now since the modification with the appearance of the GI, we have something more prominent to talk about as the weight factor. So many times, even in the problems, they don't ask you to calculate the degeneracy factor, but they ask you to calculate the weight factor. Or one of the data which might be giving you is not the degeneracy factor, it is a weight factor. Actually, weight factor is GI. So because now the GI plays the role of weight factor for a level EI. So that is the situation right now. So keep that in your mind. Now, so this is a situation in which we are summing the levels, like which means that you are talking about really discrete levels where you can really take each level into this one. But more realistic picture will be when we assume that these degenerate levels are really close to each other. Not only the degenerate levels, even the levels in themselves are very close to each other. How do I write that? In certain cases, the energy levels EA are really close to each other, and thus it can be considered as a um, as a continuous variable. Right. Therefore, I can write now the PD can be written as exponential, right? Do you remember that derivation, right? This was how we wrote down the expression for PR, and then we got into the expression for partition. So PD is directly proportional to exponential minus beta E GD, right? Yeah, exponential minus beta E GD. Now we need to introduce a normalization factor. On introducing of the normalization factor, I can modify the expression by introducing the what the partition function, right? You remember the derivation. Hope. So PD can now be written as exponential minus beta E GD divided by integral of 0 to infinity exponential beta minus beta E GD. Right. So right, and so this expression 3 is now getting modified as expression number 4. This is a new kind of expression, you can call it, right? So now this partition function, now the new partition function, I can write it as QNBT is equal to integral 0 to infinity exponential minus beta E GD. Right, so this is the new expression for partition function, and this expression we will try unless there is a specific case where we don't see the chance for a continuous variable, we will start using this expression for our real situations which we will be solving in some of the videos which will be following this. Now for a physical quantity like where we have written the expectation value, the ensemble average, that expression can now be written as, if I take the discrete level situation, say F is the physical quantity, I can now write it as expectation F equal to sum over I Fi Pi, and I can write it as sum over I Fe into Gi exponential minus beta Ei divided by sum over I Gi exponential minus beta Ei. I just told you because in some situations, if you want to use, you can always use this. And always there is a chance for you to modify this expression also in the lines of continuous variable. So for a physical parameter, you can just put this Fe also along with the weight factor, so that you will get an idea of the partition function. The expectation value of the physical quantity. Okay, so that's it, and that's the alternate expression for the partition function. So note down those expressions.